Welcome GeoTrig. This video is on trigonometric functions. Let's begin. We've done this before, but I think we focused on the sine, cosine, and tangent, and we really didn't talk much about cosecant, secant, and cotangent. So this video, just jump around to what you need to, but I'm going to make sure I emphasize those. So, a lot of information on here. If we're talking about a unit circle there, I'm going to sum it up for you here. When we're talking our sine values, we want some point P that's on the unit circle. The sine at t is going to equal to the y coordinate of that point P. The cosine is going to be the x coordinate. The tangent is going to be the y coordinate divided by the x coordinate. Cosecant is basically the inverse of sine. So it's going to be 1 over the y. Secant, not the inverse, the reciprocal of cosine is going to be 1 over x. And cotangent is going to be the reciprocal of tangent, x over y. Another way to write these reciprocal identities, and maybe it's just easier to write this in your notes, is right here. I would write everything down really neat, and just eventually you should memorize all these. But these identities are perfect right here. I always get confused with the sine and cosine and the secant. I just have to remember myself that it's the opposite letters. So the S, it's not sine and secant, it's sine and cosecant. So the S, and one's S and one's got to be C, or one's C and then the other one's S. So just remember opposite letters. All right, so what I want you to do is I got this point P. It's at square root of 2 over 2, square root of 2 over 2. And this is when the arcs, or it's pi over 4 radians. I want to evaluate each of our trig identities. So sine of pi over 4 is going to be our y value, so that's going to be radical 2 over 2. The cosine is going to be the x value, so it's radical 2 over 2. The tangent is you're dividing it, so it'll be radical 2 over 2 divided by radical 2 over 2. Well, it's the same thing divided by the same thing. It's going to be 1. Cosecant is 1 over sine, so it's basically flip this. It's going to be 2 over radical 2. We don't like radicals in the bottom, so I'm going to multiply by radical 2 on the top and bottom. So what you're actually going to get is 2 radical 2 over 2, and those are going to cancel, and it's really just radical 2. Secant is going to be the same deal. It's the same math behind it because you're flipping the cosine, so it's also going to be radical 2. And cotangent, you're flipping 1, well, it's still going to be 1. All right, there's this concept of odd and even functions. So cosine and secant functions are even, so that you have a cosine of the negative of something, it's going to equal the cosine of the positive of that. Same thing with secant. Sine, cosecant, tangent, and cotangent are odd functions, so that means is this formula right here. Yeah, so let's apply that. If we have secant of pi over 4, it equals the secant, or negative pi over 4, it equals secant of pi over 4, which is going to equal, secant is going to be 1 over cosine of pi over 4. And if you know what cosine of pi over 4 is, that's radical 2 over 2. And that's what we just did, so it's going to equal radical 2. Okay, so sine is negative pi over 4. Sine of negative pi over 4 is negative sine of pi over 4. So it'll be negative radical 2 over 2, because this is radical 2 over 2. And just a negative of that. All right, next thing. Given a sine of t is 2 over 3 and cosine of t is radical 5 over 3, find the value of each of the 4 remaining trigonometric functions. How do I do this? Well, what I like doing is I like drawing a right triangle. This helps me out here. So let's call this t. So sine is going to be opposite 2 over hypotenuse, thirds. And cosine is going to be radical, the adjacent over opposite, so that's going to be radical 5 over 3. So these are our trigonometric ratios if we're making our right triangle right here. So using that to draw that picture, now that I have this picture, I can figure out the rest of the trig functions. So tangents, sine over cosine, so I can say it's 2 over 3 divided by radical 5 over 3. And what's going to happen when you're doing that, they're the same base. These radical 3's are going to cancel out, so it's just the same thing as 2 radical 5. I don't like radical 5's in the bottom, so I'm going to multiply it by radical 5 over radical 5. So you get 2 radical 5 over 5 for tangent. Now let's try, the next one. Let's go cosecant. This is the same thing as 1 over sine, so cosecant of t is going to be the reciprocal, so 3/2. Secant is going to be the reciprocal of cosine, so it would be 3 over radical 5. Again, I don't like radical 5's in the bottom. So it's going to be 3 radical 5 over 5. Now we've got to go to cotangent. So it's going to be flip this guy around here. So tangent And we can actually go, we can just flip this around, or we can actually flip this one around. It's just going to be radical 5 over 2, because that's what we originally had. So there you go for those. Last thing, Pythagorean identities and periodic properties. We'll cover this more later. Just throwing this at you now. This is, especially this first one here, that's going to be huge. You're going to have to memorize that eventually. So sine squared plus cosine squared equals 1. There's a lot of neat properties with that. And then these ones kind of follow the same idea. Periodic properties, when we start graphing these, what this is saying here is that when you graph a cosine or sine function, you might remember a little bit from algebra 2. It repeats a period, and that's going to repeat every 2 pi for sine and cosine. This is the sine function. This is roughly the cosine function. And it's going to repeat every 2 pi. So that's what that's saying. Let's do some examples. Okay, evaluating negative 11 pi over 6. So really, you want, this is something that you're going to have to memorize or know from the unit circle. And if you have the unit circle in front of you, cosine is going to be whatever the x value is at that point, right? At a negative 11 pi over 6. So what I like doing, I'm going to draw a picture. And negative 11 pi over 6 comes up to all the way up to here. So 12 pi over 6 is, that's going to be like one full revolution. So that's almost a revolution right there. And what you're basically going to have left, it's going to be coterminal to pi over 6. That's how I remember that. It's going to be coterminal pi over 6. And the x value at pi over 6, oh boy. Let's go back to our unit circle from that first. Do I have that first slide? Because I don't want to get it wrong. I really don't. So if we go back to that first one, pi over 6. Oh, that one doesn't have the information. Okay, I believe cosine, or you could just plug this into your calculator if I wanted to check, but I don't want to do that. X value, it's 1/2, I hope. Oh well, let's see if that's right. Next. Alright, so we got this point on a unit circle, find the values of the trig functions. Well, the first sine and cosine are easy. So the sine value at t is going to be the y value, so negative 4/5. The cosine of t is going to be the x value, so 3/5. And the tangent is going to be sine over cosine, so negative 4/5 divided by 3/5. And what's going to happen is those 5s are going to cancel. So you're left with negative 4 over 3. All right, let's do cosecant. So cosecant is the reciprocal of sine. So cosecant of t is going to be negative 5/4. Secant is going to be the reciprocal of cosine, so it would be 5/3. And cotangent is going to be the reciprocal of tangent, so negative 3/4. Wow, that's easy. That's it.